Today, I'll talk about the problem spinning wheels. This problem is actually rather simple. In this problem, all you need to do is just simulate the spinning of each wheel and check if any of the wedges fitting together. So here's the code. There really isn't much. All you need to do is know how you can implement this, and you can just check each rotation one by one. So here I will read in a few inputs. First the speed, and then how many wedges there are for each wheel, and then for every wedge we have to check reading the initial angle and extent. So the extent is really just how big the gap is for this wedge, and then here we'll use this answer and check each of this from 0 to 36. You only need to check from 0 to 36 because after 36 everything will just restart, and it will just be the same as 0. 36 will be the same as 0, so it will just keep on going forever. And the other reason is that we need something to stop at, so then just in case if there is no solution, we will just print out none. And we'll use this check function to check if all the wedges can fit together. So first I created this array called count, and it has 360 size in there because this will keep track of the angle for each. And then here we will create a double loop, and the first loop outside here will check each of the wheels, and the second one will check each of the wedges on the wheels. So first we will get the initial angle of this wedge, and then we will we'll receive in an input, and this will mean how long has already passed since the beginning. So the speed would just be the time multiplied by the speed of the wheel. So this will get us the final angle of this wheel, of this wedge, and we have to modular this by 360 because as I said, if you just go a whole round, you will start back at 0 again. And then this is our the maximum gap that it covers. So the maximum range that it covers will be the angle that we've already got plus the amount of extent that this wedge have. Also modulate this by 360, and then here we will just increase all of the count from this initial angle to our maximum possible gap. So here I didn't do k is smaller than m. I did k is not equal to m because here we will still increase k by 1 every time, but we also have to modulate this by 360. So here every time we are at a new angle, we just increase that angle count by 1. And also, since this uses not equal, then at the end when it's equal to m, this will stop already. But we still didn't count the 1 for m yet, so we'll have to increase 1 for this angle m as well. And then after we've checked each of the wheels, we will know how many of the open angles we have. So we will loop all the way from 0 to 360 to check which one of them have a count of 5 or greater, but I think you don't need to really put in the greater. I did it just in case we have any too big numbers or anything. So if it's equal to 5, then that means all 5 wheels have an open wedge in that angle. Then we will return true for this one, meaning that this one will be a possible solution. And right after we find a possible solution, if we don't find a possible solution, answer will just keep on increasing, and it will just keep on looping until we find a possible solution. And since here I make sure that the answer is less than 360. If it is equal to 360, then that means we didn't find any solution. Then we will just print out none. Otherwise, we can just print out the answer and stop this program.